The Trials and Tribulations of an Engineer. Episode 10, HVAC Consultant. After a couple of years in the construction management job arena, I decided to try a job in a slightly different field and put my calculation skills to the test. After some searching, I was accepted at a well-known firm for mechanical, electrical, plumbing and fire protection design. The reason why I chose this firm was because it was a smaller, more family-oriented business, and I felt that I would get more one-on-one mentoring and enjoy the environment better. The hierarchy there was, from the bottom to the top, a CAD operator whose sole job has everything to do with AutoCAD, designers are people that just graduated from college, design engineers are just the next level up from the design route. The last level in the non-managerial side of things is an engineer. This is the level where you start to get respect in terms of your knowledge, and then your career options split up into divergent paths. On one side you have the senior engineer. This is a managerial project management position, but as far as this hierarchy goes, it is the top rung and it ends there. On the other side of the career path split, you can become an associate, a senior associate, a vice president and a president. This is the path for the more ambitious worker. It should be noted that you can get overtime for hours worked over the standard 40 hours per work week up until the engineer level. After that point you have to hope for a good bonus at the end of the year. It should also be noted that below associate and senior engineer there are no bonuses. When I started out, I was put on a team that specialized in laboratories. To say that this is a difficult niche is an understatement. You see, with laboratories you have to be cognizant of where the air flows between each room, because there may be toxins in the air of a test room that if the air travels from a contaminated room to a clean room, then you put people's lives at risk. After working a few years in those types of projects, I began doing government office building fit-outs and then moved over to high-end residential apartments. The first thing that they will let you do in a new project is to translate the drawings that they received from the architect. This involves making all the layers gray so that they show up light, and making sure that the orientation of the file is at the origin of the drawing, 0,0. You would also do something called exploding the drawings, which means in AutoCAD that you would remove items that are grouped together as one piece into their individual parts. Another important step in this portion of the job is to do something called storybooking, which is basically creating the outline of the drawing layouts. As a general rule, you typically have the following pages at a minimum: a drawing list, a symbols list and legend, a scope of work, floor plan drawings for both ductwork and piping, section views, riser diagrams, sequences of operations, details, and schedules. The second thing that they will let you do in the HVAC field with a new project is to do area takeoffs, where you have to measure out every single room and find out the square footage of the rooms. To be efficient with your time, find out the heights alongside with the areas, because you will need this information to find the volume of air in the room. Normally you would put this data into an enterprise program like Train Trace or Revit to calculate the heating and cooling loads, but because of the complexities of a laboratory and the many different types of rooms, this must be done manually in a spreadsheet to calculate the loads. Just a note, when using any HVAC load program as well as the Excel method, you must take into consideration the orientation of the building. Because of the way that the sun moves in the sky, the heat provided by the sun on each side of the building differs, i.e. it is warmer on the southern exposure and colder in the northern exposure. This process will be repeated multiple times. In fact, it is repeated as many times as the architect changes the orientation and sizes of the rooms. This can get quite frustrating for people who don't enjoy doing iterative processes multiple times. In the third step, you would mark down the load per room and start to create a one-line path for the ductwork to run. While planning this path, you have to take into consideration any obstacles that may be in your way. If there is a ceiling, then you must ensure that there is enough clearance not only for your stuff to pass but for all the other trade stuff as well. In the olden days it was more difficult to do this coordination process because you were stuck in 2 dimensions. Now more and more firms are moving to 3D drafting that illustrates where all the collisions happen in 3-dimensional space. The only drawback to this is that the computers that run the software have to have bleeding edge specifications in order to run at a reasonable speed. The 3D files also take up a significant amount of storage space, and that is another drawback that prevents some firms from doing 3D modeling. A procedure that would happen before the third step but not necessarily by a new engineer is the layout of the mechanical rooms. This is typically done by a more senior engineer because oftentimes the mechanical room is barely made big enough to house all the equipment necessary to cool and heat the building. This room is where truck-sized equipment is placed to support the building's temperature and water infrastructure. The other thing that the senior engineer would work on is the sizes of all the shafts in the building. This is a very important step that the architect needs in order to finalize their room layouts. If you are unsure of what a shaft is, think of elevators and the pathways that they have to go up and down, and now just imagine ductwork and pipes instead of an elevator. Shafts can also travel horizontally through a building, by the way. All of these steps have only lightly been touched upon for what is known as the schematic design phase, or SD phase for short. There are two other phases known as the design development phase and the construction design phase, or DD and CD phases respectively. Ultimately, all these phases can take anywhere from a couple of months to a few years depending on the size of the project. If this information helped you in any way, please consider liking and subscribing. Till the next time.